In this section, we're going to talk about bisectors. And I figured this is a good time to also start introducing you to the idea of constructions. In geometry, usually the one of the traditional things that we talk about in geometry is construction. In other words, we're armed with just a compass and a straight edge. We make things. For example, we use that to construct, to draw a bisector of a segment, an angle. We use the compass and a straight edge to make different geometric constructions. Now, for example, the thing about it is we just have a straight edge and we just have a compass. And this straight edge, we're not going to use it to measure anything. We're just going to use it to draw straight lines. Now, one of the things that I've included instructions for how to construct a perpendicular bisector. And it's something that we're not going to spend a lot of time on, but I do want to draw your attention to it, something you can play around with. Let's suppose that we've got a segment here, AB, and we want to construct a perpendicular bisector for this segment. Now notice these instructions up here. You take the compass and put right here on this point where you want. I'll call it C. You take your compass, put it there, and extend it out to B, and then make a half circle. Just half circle, and it will pass through B and A. Then you take your compass and you put the needle point over here on B or A, it doesn't matter which, and you extend out the compass so that this end is over here at length A. So the compass is a little bigger, and from B, you go up here and you make a little arc. Then you do the same thing over here with A, you make a little arc. Now, when you've done that, you can use your straight edge to just draw a little segment down there, and you'll get a perpendicular bisector. So let me just take a minute and draw something, and we'll call it a perpendicular bisector. Okay. There's a perpendicular bisector, and notice it is perpendicular, so that line down there, or that line is perpendicular to AB. Okay, now I want to do this. Let's suppose there's a point up here. And let's suppose this point is, I'll just call it D. Okay, D. And I will connect down here with this line A and connect over here with this line B. Okay. I didn't do it exactly right. It looks a little bit off to me, but anyway. Okay. So now notice I've connected those lines. Now, if you think about it, this distance right here is going to be the same as this distance. Okay? In other words, AD would be equal to DB. Or AD, I'm sorry, AD. AD is going to be equal to BD. Right? If you think about it, that makes really good sense because it's a perpendicular bisector. In other words, the distance from D to A is going to be the same as the distance from D to B. For any point on this perpendicular bisector. Now, here's the point. Any location on here, if I choose right there, and I look at the distance from that point down to A and this point over to B, that distance is going to be the same. It's going to be exactly the same distance. Okay? So that seems pretty obvious to us. Now, if you think about this is only going to happen if you have a point on that perpendicular bisector. Okay? Now notice this, that these lines down here are also the same. So AC is equal to BC. And of course, DC is equal to DC because it's itself, reflexive. Okay, reflexivity. Okay, so it's the reflexive property. A segment is congruent to itself. So look at what we have here. We have two congruent triangles. We have, and you could say, well, why are they congruent? Well, side, side, side for one thing. So these two triangles, this triangle ACD is congruent to triangle BCD. Okay, by side, side, side. So you can see that. Now, another thing you see is you see that this angle is congruent to this angle, and this angle is congruent to this angle. So just some things that we're taking note of about these angular or these perpendicular bisectors. Now, something else we need to take note of. I said that this distance here, AD, is congruent to BD. But here's another thing we can take note of about this, and see if this makes sense. If I go to any point on this perpendicular bisector, and I measure the distance from that point over here to this line, in other words, I calculate this distance right there. That's going to be the same distance to each of these lines. Okay? So if I go from any point on this perpendicular bisector, I'm going to find that it's equal distant to both of the lines. Now, when I talk about distance, what I'm talking about is this. If I want to know the distance from this point to the line, then I go over there to the line and I make a perpendicular little segment. I find the perpendicular segment that goes out and catches this point. And the length of that segment is called, we're going to call that the distance. So you might say, well, how do you know what the distance is? In other words, there may be some ambiguity. Is the distance this line, what is it? How do we, when we talk about distance, what are we talking about? Well, you go over the segment, make a perpendicular that hits that point, and that's the distance. And what we're saying is that if a point is on that perpendicular bisector, then it's going to be equal distance to both lines. Now, the converse of all that is true as well. The converse is true. So if you have a situation where you have a point and it's equal distance to both of the sides, then you know that that point is on the perpendicular bisector of the segment. Okay, so this is some of the properties that we observe from perpendicular bisectors of segments. Now, you could also have a bisector of an angle. So let's just draw an angle here. Okay, here's an angle, and here's another angle. Okay, well, now let's suppose that I have a bisector. In other words, I want to cut this angle in half. This angle, I'll call this angle A. I want to cut that angle exactly in half. I want to bisect it. Okay. So there's a way to construct a bisector like this, such that this and this are the same. So those two angles are the same. Now, if we go to any point on this line that's on the angle bisector, and I go over here, let me see, and I measure the distance. Okay. That right there, that distance. And then I go over here and measure this. Okay, well that's perpendicular. Then one of the things we know for sure is this distance and this distance are the same. Okay, so that's one of the things we want to note about angle bisectors. Now, in fact, the converse is true. So if you've got a point on an angle bisector, it's going to be equal distance from the sides, both that form the angle. Now, the converse is true. If you do have a situation where you have a point and it's equal distance to this side and to this side, those distances are the same, then that point is on the angle bisector. Okay. Now so we're talking about bisectors in this section. Now what I've got over here is I've got the summary I've got the theorems that talk about these, and then there are some practice problems down here. But notice I have down here just, kind of a practice. Let's suppose that D is on the angular bisector, okay? So we're just thinking about a proof here. Okay, so it bisects this angle BAC. And what we note is that DB, okay, DB is perpendicular to AB and DC is perpendicular to AC. So as you can see in the figure here. And what we want to do is we want to prove this. We want to prove that DB, okay, DB is congruent to DC. In other words, I'm trying to prove what I just said was true. Now think about how you would do that. You've got two triangles here. Okay, two triangles. And what do we know about that? Well, we have these two angles. We have this angle and this angle are congruent. Certainly this angle and this angle are congruent. And dig this side is congruent to itself. Okay? So notice we have this. We have angle and we have another side here. So we got to think about, okay, how could I show that DB is equal to DC? So let's think about how we would prove this. Now notice, let me just erase some of this. Okay. So think about this. Obviously, this angle is congruent to this angle. Okay, because they're both right angles. This angle is congruent to this angle by definition of angle bisector. And this side is congruent to itself. So look what we have here. We have angle, side. Therefore, those two triangles are congruent. Therefore, DC and CD are congruent. Yeah. So that's the idea with this section.